Okay, continuing on 6-1, this is number 3. We again have y equals x to the 6th, y equals 1, the y-axis, so that bounds this region, and we're going to rotate it around the x-axis, so around this. This is my axis. So this would come down to -1, from 1 above the axis to 1 below the axis, and the curve would come out and go through here, something like that would be the region, and it's coming out, around, and down. So I'll make a try to represent that like that, and this would come this way, and yeah. So it's not this piece, it's this stuff. Okay, so if we do the disk method, it'll actually be a washer method, because when we slice it perpendicular, for disk method, we slice perpendicular to the axis. So we'd have a slice that goes like this, and it would be down here, and there will be a hole in it. So it'll be the integral of pi large radius squared minus small radius squared. D, oh, what's my thickness? That's this way. It's a slice down here. So its thickness is in the x direction, so it's dx. And x would be evaluated from 0 to 1. Now we just have to get r's and r's in terms of x. Well, x goes the wrong direction. To get to a point on the curve, like I've been trying to tell you, it's going to be, the point is x, y, and x is this direction, but we want the radius, which is in this direction. The inside radius here would be simply y, but the outside radius goes clear up to here, and that outside radius will stay the same all the way along. So the big R is just 1, and the little radius is y. But those are not in terms of x, so we're going to have pi integral from 0 to 1 of 1 squared, that's fine, minus y squared. Well, y is x to the 6th, so that would be x to the 6th squared dx. So this would become pi, antiderivative of 1 is x, antiderivative of x to the 12th is 113 x to the 13th. And fortunately, we're doing nice numbers, 0 and 1. They're easy to take to the 13th power. Otherwise, this could have gotten really ugly. So we get 1 minus 1/13, and then put in 0, we get nothing. So 1 minus 1/13 is 12/13. 13/13 minus 1/13 is 12/13. So we get pi times 12 over 13. Now let's do it with the ring method. So the ring method, we slice parallel to the axis, so I'll do it right here. And that would revolve around down to right here, forming a pipe that would look like this. So it's a thin-walled pipe. The thickness of the wall is in the up-down direction, so it's a dy thickness to my pipe. And the formula is 2 pi r h thickness dy. So now I need to know the height of my pipe. Well, the height is laying on its side, so the height is this way, and the radius is this way. And the y is going to be integrated. The y is going to go from 0 to 1. So what is r? R is from here up to the curve. To the curve, the point on the curve, again, is x, y. Get used to that. You go over x and up y. So this is y. The radius is y. The height is this direction to the point of the curve, and so that is x. So what we'll have is 2 pi integral from 0 to 1 of y, let's see, dy, oh, we want y, so that stays y, and x, see, x, we'd have to take both sides of this to the 1/6 power. So x would be y to the 1/6. Okay, so that would make y to the 1 times y to the 1/6. When you multiply, you add the power, so we get 2 pi integral from 0 to 1 of y to the 7/6 power. Now adding 1 to that, we get 13/6. 7 plus 6 is 13/6. So we'd get 2 pi y to the 13/6 divided by 13/6, or times 6/13, evaluated from 0 to 1. If you put 1 in here, you get 1 times this, which is 2 times 6, 12/13 pi. And if you put in 0, you get 0, and we've got the same answer.